Imagine standing at the helm of a multi-billion-dollar company, about to make a decision that will ripple through its future for the next decade. Do you know the invisible blueprint guiding every piece of software, every system, every critical data point that underpins that decision? What if there was a way to truly master that blueprint, to understand the intricate technological nervous system of an entire enterprise before you even write a single line of code or launch a new product? Get ready to level up. This deep dive is your essential guide to understanding the tech that's reshaping every industry, giving you the power to not just navigate, but design the future. Today, we're unraveling the intricate world of enterprise architecture, or EA. It's far more than just what computers do. It's about how entire systems are strategically designed and managed to flawlessly execute on core business strategy. We're pulling insights from foundational texts by Spark Systems on enterprise architecture, alongside crucial perspectives on the Internet of Things from the National Telecommunications and Information Administration, and even, the broader societal impacts of technology.
Yeah, and our mission today is clear. To equip you, as future business leaders and information systems professionals, particularly those of you from the Dr. Ciampa College of Business, with a truly holistic understanding of how technology underpins and, drives business success. We'll dive deep into the frameworks and tools that allow organizations to align their IT infrastructure with strategic goals, proactively manage risks in our rapidly evolving digital world, and ensure that every technological application serves a clear, quantifiable business purpose. This deep dive is really about gaining a strategic vantage point, preparing you to not just use technology, but to effectively shape its application for significant professional growth within any industry.
Okay, so before we plunge deeper into this fascinating topic, make sure you hit that like button, subscribe to the deep dive, and share this with anyone looking to get smart fast. You really don't want to miss our insider tips that could position you for a truly bright future. And remember, all the extra resources we mentioned, they're waiting for you in the description below. Okay, let's unpack this then. Enterprise architecture. It might sound like a mouthful, but strip away the jargon. And it's essentially the master plan, right? The grand blueprint for a company's entire technology landscape. Think of it like designing a sprawling modern city before you even break ground. You need a detailed plan for everything, from the major highways and side streets, those are your networks, to the individual buildings and districts, your applications. And even the hidden utilities like water, electricity, and waste management, which, represent your data. It's about creating a coherent, integrated vision for how every single piece fits together, making sure it serves the city's purpose.
That sense of coherence you're talking about sounds absolutely critical, especially in a rapidly growing or complex company, because precisely without that unified view, an enterprise's IT systems can quickly devolve into what we sometimes call chaotic sprawl. It just gets messy. Imagine a symphony orchestra where every musician decides to play their own piece at their own tempo without a conductor. The result isn't music. It's noise, fragmentation, incredible inefficiency, and frankly, skyrocketing costs. EA provides that single, clear, and integrated perspective, preventing that kind of chaotic sprawl before it costs millions in wasted effort and missed opportunities. It's truly like a conductor orchestrating a symphony, ensuring all the instruments your various IT systems play together harmoniously, all working towards delivering that common piece of music, your overarching business goal.
I love that symphony analogy. It really brings to life the idea of everything working together harmoniously. But if we're designing a city or orchestrating a symphony, it's not all at one level, is it? There are different layers. And here's where it gets really interesting, I think. Just like a city plan has different scales, you've got your high-level zoning map showing major districts, right down to detailed building blueprints for a single structure. Enterprise architecture operates on several distinct levels. This multi-layered approach is absolutely essential for managing complexity and ensuring that the architectural plans remain relevant for different stakeholders, whether they're in the C-suite making strategic decisions or on an implementation team actually writing code.
Indeed, these layers are how we translate those grand visions into actionable reality. At the very top, we have strategic architectures. These provide that high-level, often long-term view of the entire enterprise, looking out 5, maybe even 10 years. They're primarily used by senior business and technical leaders for critical strategic planning, like setting the company's overall direction. For example, a global corporation might develop a strategic technology roadmap, outlining its plans for entering new markets in Asia. It focuses on broad technological capabilities needed for that expansion, rather than specific software choices at this stage. It's really about defining the destination, not mapping out every single turn just yet.
Okay, so if Strategic architectures are the destination, the big picture. Then moving down from that bird's eye view, we encounter tactical architectures. These sound like your mid-range plans. Is that right?
Exactly. They're all about taking those big, bold strategic architectures and partitioning them into more manageable, actionable groups or chunks. They often focus on a particular area, a specific division, or maybe a major program within the company. Think of them as representing portfolio or program-level plans designed to achieve those grander strategic goals over a period of, say, a few years. They act as a crucial framework for organizing those individual solution-level initiatives, making sure that every project ultimately contributes tangible business value. You need that link.
Gotcha. So like an example might be maybe the IT plan for integrating a newly acquired company's systems over, say, 3 years.
Perfect example. That's exactly the kind of thing. And roadmap diagrams are absolutely key here. They visually sequence these initiatives across various architecture types over time, showing you the stepping stones, the path to that strategic future.
Right, the stepping stones. I like that. And then down at the most granular level, the most detailed, we have solution architectures.
Precisely. Solution architectures. These provide a highly detailed view of how an enterprise supports a specific capability. For instance, a very precise function like voice-directed picking in a modern warehouse, or maybe a new customer onboarding workflow. They meticulously describe both the baseline, the current state, and the target, the desired future state of those capabilities. Their main purpose is to guide individual projects, making sure they deliver precise incremental improvements to specific capabilities.
Okay, so like the detailed design for a new mobile inventory management app, including all its integration points and data flows and the specific tech underneath.
Exactly that. These are the blueprints the builders, the developers, actually use day to day. Each of these levels, strategic, tactical solution, is crucial for translating that high-level vision into actionable plans, providing clarity all the way from the boardroom down to the dev team. And if we connect this to the bigger picture, these hierarchical levels aren't just abstract concepts floating around. They apply across specific functional domains within the enterprise. The overall architecture of any organization is really described by 4 integrated sub-architectures, you could say. Each of these is absolutely critical for forming a truly holistic view of the enterprise's technological landscape, much like, different sections of that city plan we talked about.
Okay, 4 sub-architectures. Let's break those down. What's the first one?
The first, and arguably the foundation, is business architecture.
Business architecture.
Okay. This pillar defines the very essence of the enterprise. Its mission, its vision, its core capabilities, the underlying processes, functions, key drivers, goals, objectives, the whole 9 yards. In essence, it describes what the business does, and maybe even more importantly, why it does it.
So we're talking about things like the company's mission and vision statements, like our customers are our priority, or to be the leader in knowledge products.
Exactly, those high-level statements. But also identifying core business capabilities, things like sales and marketing, order management, warehouse management. What does the business do? It also details the drivers behind change. For example, if order errors have increased to an unacceptable level, that's a driver. And that driver then cascades into specific goals and objectives to fix it.
Right. And for anyone looking to lead in business, understanding this seems vital because it helps you grasp the strategic why behind any technology investment, right? How can technology directly support a business's core purpose and desired future state? It feels like this directly links to those foundational BCIS 1305 concepts around business productivity and aligning technology with organizational goals, ensuring your tech investments actually, move the needle for the business.
Absolutely. You've hit the nail on the head. It ensures tech isn't just tech for tech's sake. Building on that why, the second pillar is information architecture.
Information architecture, so data.
It's essentially yes. It's absolutely crucial for understanding the lifeblood of any modern organization. It's information. It clarifies how information is created, consumed, and ultimately destroyed or archived across the entire enterprise. It answers key questions like, which functions and processes use specific pieces of information? Where does that information actually reside? And precisely how is it manipulated throughout its life cycle? This involves creating conceptual information models, those high-level diagrams of important entities like a catalog, item, order, or account, basically the core business vocabulary of your data. It then progresses to more detailed logical and physical data models, schemas, and messages. A really key concept here is understanding which systems serve as the master records for critical information, ensuring data consistency and integrity across the entire organization. You need that single source of truth.
That makes sense. For business professionals, this sounds like it directly addresses data analytics and database concepts. It highlights that data isn't just a byproduct of operations, it's a strategic asset that requires careful architectural management across the whole enterprise, not just siloed within individual applications.
Precisely. Neglecting this is like having a library where no one knows where any of the books are or which version is the correct one. It leads to chaos.
Okay, so business architecture sets the why. Information architecture deals with the what, the data, what's next.
Next up, we have application architecture.
Application architecture, the software itself.
Yes, exactly. This pillar is all about cataloging every single application within the enterprise, every piece of software. It details their specific functions. Are they transforming data, transmitting it, sorting information? What do they do? It looks at their interfaces, meaning what they require from and provide to other systems. How do they talk to each other? And most importantly, how do they interact with each other to support those core business activities we defined in the business architecture?
Okay, so we're talking about creating comprehensive application lists, maybe communication diagrams, like showing an accounting system, seamlessly talking to a customer relationship management system, perhaps using something like a RESTful API.
Exactly. A RESTful API is a perfect example. It's like a standardized set of rules, a common language, allowing different software applications to communicate and exchange data over the internet. Think of it as a universal digital translator between systems. It also includes comprehensive interface lists. It's about linking business capabilities to actual software solutions and understanding how those applications fit into the overall business processes.
For us as future business leaders, this seems crucial for understanding how different software applications, even ones that seem totally separate, actually work together, or
Yeah.
sometimes spectacularly fail to work together. It really emphasizes the integration of various business software applications, which is so central to modern operations, right? Preventing that spaghetti mess where systems are just tangled and don't communicate efficiently.
You got it. That spaghetti mess is exactly what application architecture aims to prevent or untangle. Finally, underpinning all of these other layers is the technology architecture.
Technology architecture, okay, the hardware and infrastructure.
Precisely. This layer describes the logical, physical, and virtual infrastructure, think hardware, networks, operating systems, databases, that literally supports all the application services and business functions we've discussed. It includes concepts like application platform services and a technical reference model, or TRM. A TRM is essentially a standardized blueprint or maybe a menu of approved technology components and services and enterprise uses. It ensures consistency and compatibility across the IT landscape, avoids random tech popping up everywhere. It also accounts for infrastructure facilities like data centers, corporate offices, warehouses, the physical places where tech lives. Deployment diagrams are really key here. They show hierarchies of client computing devices, notebooks, tablets, smartphones, or even server environments like Dell Blade servers running Red Hat Linux Enterprise. They illustrate how these components are physically and logically deployed across the organization.
For business students, this connects directly to IT fundamentals, hardware, software, networks, things we learned about early on. It demonstrates that even something seemingly abstract like cloud computing still relies on robust underlying infrastructure. It's not magic. And understanding these layers is essential for building and maintaining reliable and secure systems.
Absolutely. You need that solid foundation. But, and this is important, the scope of this technology architecture isn't static. It's constantly being reshaped by innovations like the Internet of Things or IoT. IoT introduces entirely new layers of complexity that demand really careful consideration. The introduction of IoT devices, think smart machines in a warehouse, sensors embedded in critical infrastructure, fundamentally expands the scope of this architecture. Each connected device, from a smart thermostat in an office to an industrial sensor on a manufacturing line, becomes a part of the enterprise's technological footprint. And with it, naturally, the potential attack surface grows.
Right, more devices, more potential entry points for trouble. But it's not just about the sheer number of new devices, is it? I think the National Telecommunications and Information Administration, the NTIA, emphasizes that an increased number of vulnerable devices doesn't automatically translate to an increased risk. It's more nuanced.
That's a critical distinction.
Huh.
Often the benefits of adopting IoT, things like improved efficiency, predictive maintenance, maybe entirely new service offerings, far outweigh the potential for harm. In fact, the NTIA points out a often overlooked risk, that premature or maybe overly aggressive security measures could actually stifle economic growth and innovation.
Yeah, imagine if we'd paralyzed the early internet with too many regulations just out of fear. We might not have what we have today.
Exactly. So when we assess risk for IoT devices within our technology architecture, we need to apply specific, granular metrics. The NTIA suggests three key differentiators: the value of the data being generated, the criticality of the function the device performs, and the scalability of failure.
Okay, break that down. Value of data, like tire pressure data versus personal health data.
Precisely. Real-time tire pressure data might have relatively low value compared to sensitive personal health records or financial transaction details.
And criticality of function, annoying versus life-threatening.
Exactly. An IoT device that simply makes turning off your air conditioning a bit annoying if it fails is far less critical than one controlling, say, a jet engine in flight. That could be catastrophic.
And scalability of failure, single device versus mass effect.
Right. A single smart light bulb failing has a different impact than a vulnerability, allowing someone to switch off power to thousands of homes simultaneously through smart meters. Devices that create highly valuable data, perform crucial functions, or can produce mass effects need to be held to significantly higher standards, often requiring government or industry-wide action. Those that don't pose such high risks can often be left more to market forces, balancing innovation with pragmatic security.
Autonomy is another critical aspect, isn't it? The NTIA mentions that. The more autonomous an IoT device is, especially in sensitive functions, the higher the potential risk.
That's right. Limiting device autonomy or providing clear, reliable override capabilities significantly reduces that risk. Think of an autopilot system in a plane. If human pilot skills degrade due to over-reliance on automation, an abrupt transfer of control back to the human in an emergency can actually increase danger because the operator isn't prepared.
Ah, interesting point.
So IoT standards should ideally require a higher degree of human intervention and control for those sensitive high-impact functions. This directly feeds into the design decisions we make for our technology architecture. It's about designing for effective human-machine collaboration, not just blind automation.
And of course, security is paramount across the entire EA, but especially with IoT.
Absolutely. For IoT devices, this means emphasizing the need for robust encryption, strong authentication mechanisms, and increased resilience for both the devices themselves and the networks they connect to. You can't secure one without the other.
Like a fortress with an open drawbridge, a secure device on an unsecured network doesn't help much.
Exactly. And this aligns perfectly with the EA's overall goal of integrated secure systems. It's also worth remembering that risk is dynamic, it's not static. It generally decreases as technology matures and as familiarity and experience grow.
Like how people initially feared high-speed trains. I read something about fears of speeds over 45 miles an hour back in the 19th century.
Precisely. We adapt to new technologies. Our perception of risk changes, and architects must continuously refine their approach to security and privacy as technologies evolve and society gains experience. This connects directly back to those foundational skills and information technology concepts, hardware, software, security, and privacy, which are just so crucial for our business students to grasp early in their careers.
Okay, so we have the layers, the pillars, the IoT considerations. But what does this all mean for you, the listener? How do architects actually do this? Enterprise architects aren't just drawing pretty pictures or theorizing about grand plans. They're using specialized practical tools to make sense of all this complexity and to drive tangible business outcomes. Let's look at some of the practical applications and essential tools you might encounter and how they become your strategic advantage.
Yes, the tools are where the rubber meets the road. And what's fascinating here is how sophisticated visual communication becomes absolutely vital. These aren't just technical drawings for IT departments. They're strategic communication tools designed to convey complex ideas clearly to all stakeholders, from senior executives needing that high-level understanding to the teams on the ground implementing solutions. They create a shared language, a common ground.
A shared language. Okay, so let's explore the tools that give us this powerful visual language for understanding complex business processes and the technology supporting them. One of the first you'll likely encounter is the business process diagram, often using BPMN, which stands for Business Process Model and Notation. You mentioned that earlier.
That's right, BPMN. It's a globally recognized, standardized graphical notation for representing business processes in a clear and consistent way. Hugely valuable. Its purpose is to clearly define business processes, showing the precise sequence of activities, events, and decision points, which are called gateways. You can model processes at different levels of formality, from a simple flowchart to a really complex BPMN diagram with intermediate events and error handling.
Okay, so think of a complex supply chain constantly battling bottlenecks. BPMN isn't just about drawing lines. It sounds like it's an X-ray for your operations, instantly revealing where the gears grind.
Exactly. Mastering this can help surgically remove inefficiencies, potentially saving millions and accelerating delivery times, transforming a sluggish process into a streamlined engine.
What are the components? You mentioned events, activities, gateways.
Yeah, the basics are start, intermediate, and end events. Then you have the business processes themselves broken into activities. Gateways represent decisions or parallel paths. And importantly, pools and lanes show who is responsible for which part of the process, different departments or roles.
And the strategic advantage.
It clarifies workflows, helps identify inefficiencies, bottlenecks, redundancies, and it can even be used to generate something called Business Process Execution Language, or BPL, which is an XML-based language used for defining and automating business processes directly in software.
Wow, so it goes from diagram to actual automation.
It can, yes. For business leaders, this tool is invaluable for understanding operational flows and seeing exactly how technology automates or supports them. It's a core part of boosting business productivity and essential for that goal-seeking and what-if analysis needed to truly solve business problems. Okay, so once you've mapped out your core processes, the next challenge is often understanding that intricate web of software that brings them to life. All those applications. That's where the component diagram becomes your essential map.
Component diagram, mapping the software parts.
Precisely. Its purpose is to model the logical or physical parts of a system, think specific applications or services, and, crucially, to show how they are wired together using ports and interfaces, how they connect. Components might be a logical accounting system, communicating with a logical customer relationship management system, for instance.
And the strategic advantage there, untangling that spaghetti mess.
Absolutely. It's enormous for application architects because it allows them to describe application interaction, identify dependencies, and importantly, untangle those complex, often messy spaghetti integration architectures that tend to build up over time in large organizations. It provides a clear inventory of applications and their interfaces, which is essential for managing the sheer volume of software in an enterprise, helping avoid costly integration surprises down the road.
Okay, makes sense. Now, moving down to the underlying physical and virtual infrastructure, you mentioned the deployment diagram earlier. That seems critical for any technology leader.
It really is. Its purpose is to model infrastructure environments, whether they're physical, like in a data center, or virtual, running in the cloud. This includes servers, client devices like notebooks, tablets, and smartphones, networks, and even execution environments like operating systems and databases. Everything the applications run on.
What kind of components would you see in one of those?
You'd see things like nodes, devices, execution environments, networks, switches, routers, IP addresses, and the specific software components and artifacts deployed on them. You can even use it to show portability, for example, distinguishing between printable devices like laptops and fixed devices like desktops or servers.
And the strategic advantage, knowing where everything lives.
Exactly. It visualizes where applications are deployed, helps plan infrastructure capacity, and is crucial for understanding resource allocation, network topology, and importantly, security considerations across various infrastructure facilities like data centers, branch offices, or warehouses. This directly addresses those IT fundamentals of hardware and network infrastructure, showing how they physically support your business operations. Now, to give managers a quick, high-level, actionable view of what's going on, we often utilize dashboard diagrams.
Dashboards, like we see in business intelligence tools.
Very similar concept. Their core function within EA tools is to create high-quality charts and graphs that display information stored in the architecture repository visually. Imagine a clear pie chart instantly showing elements by priority for various project requirements, instantly telling a requirements manager about the critical tasks that need immediate attention.
Ah, so it makes complex data easy to grasp quickly.
Precisely. The real strategic advantage is in providing quick, compelling summaries for managers to monitor performance and status effectively. This directly supports data analytics and informs data-driven adjustments and recommendations, making complex architectural data digestible for executive decision-making.
Okay. What about the people involved? Is there a tool for that?
Yes, for understanding the human side of the architecture program itself, there's the organizational chart diagram.
Like a standard company org chart.
Similar. but often focus specifically on the architecture function. Its purpose is to model the organizational structure, reporting lines, and specific roles, such as an architecture executive, members of the architecture team, or maybe external consultants involved. It can even show additional relationships of authority, influence, or communication that might not follow the direct reporting lines, like dotted lines showing collaboration.
And the advantage, clarity on who does what.
Exactly. The strategic advantage of this diagram lies in helping everyone understand the team structure, how resources are allocated for architectural initiatives, and who constitutes the crucial governance bodies within the architecture program. It ensures clear accountability. Now, capturing initial ideas effectively, especially in those early fluid stages of a project or strategy session, is where the mind mapping diagram really shines.
Mind maps. I use those for brainstorming.
They're perfect for it. Their purpose is to structure thoughts, record ideas, and gather information in a flexible, graphical format, often during stakeholder workshops, focus groups, or interviews. You start with a central topic, then branch out to main topics, and then further out to subtopics. Very free form.
What's the strategic advantage in an EA context?
It's immense for capturing stakeholder needs and ideas in a non-confrontational, collaborative way. It acts as a flexible precursor to more formal requirements gathering. Plus, it provides an invaluable analysis audit trail. You can trace requirements, capabilities, and goals back to their origins in these early brainstorming sessions. That's critical for ethical business research and ensuring full traceability of decisions later on.
That traceability sounds important. Okay, one more visual tool.
Yes, for translating those high-level strategic aspirations into concrete objectives, we have the strategy map.
Strategy map, linking goals together.
Precisely. Its purpose is to model the key strategic goals an organization intends to achieve. It often links elements from the four classic perspectives of a balance, scorecard, financial, customer, business process, and learning and growth, showing how they are interconnected and how various initiatives contribute to the overall strategy.
So the advantage is seeing the big picture connections.
Exactly. The real strategic advantage here is providing a clear visual representation of how strategic objectives are connected and how different projects and initiatives contribute to achieving that overarching strategy. It creates a unified vision for success across the organization.
Wow, okay, that's a powerful set of visual tools. But it's not just about drawing diagrams, right? There must be processes behind it all.
Absolutely. Beyond these powerful visual tools, there are deep-seated processes and techniques that keep enterprise architecture living and breathing. They ensure accountability and adaptability in a constantly changing business environment. It's not just about planning, it's very much about governance and evolution.
Governance and evolution. Okay, what techniques support that?
Well, first, auditing is a critical function for accountability. It's often built into EA tools. Its purpose is to meticulously track changes to architectural content, specifically what was changed, when it was changed, and by whom. Like a detailed logbook.
Does it let you undo changes?
Not usually. That's more for version control or baselining, which we'll get to. Auditing silently records individual changes. This aids immensely in change management, governance, and quality control. The real strategic advantage is that it provides a clear historical record of modifications. That's incredibly useful for troubleshooting if something breaks, ensuring compliance with regulations, and understanding the evolution of enduring elements like architecture principles over time.
Okay, audit trails for accountability. What else? You mentioned the balanced scorecard earlier in relation to strategy maps.
Yes. The balanced scorecard itself is a truly powerful strategic management tool often used alongside EA. Its purpose is to model a balanced approach to performance measures, directly aligning business activities with the organization's vision and strategy. It does this through those four integrated perspectives: financial, how do shareholders see us; customer, how do customers see us; internal business process, what must we excel at; and learning and growth, how can we keep improving.
And the strategic advantage, keeping score.
More than just keeping score. It provides a comprehensive view to monitor performance against strategic goals, improves communication across departments by providing a shared framework, and helps managers adjust business activities to increase overall performance. It's a fundamental management tool for linking strategic goals to measurable, actionable steps, and it's very much about using goal-seeking and what-if analysis to solve problems and make proactive adjustments based on performance data. Now, to truly identify areas for improvement or plan transitions, the gap analysis matrix is indispensable.
Gap analysis, finding the differences between now and later.
Exactly. Its purpose is to meticulously record the differences between two versions of any part of an enterprise. For instance, comparing a baseline or current state architecture to a target or desired future state architecture. Or maybe comparing current capabilities to desired capabilities, or even staff competencies needed versus what you have.
How does it look?
It's typically structured like a spreadsheet. It clearly highlights missing elements, eliminated elements, or brand new elements in the target state compared to the baseline.
And the strategic advantage, knowing what needs to change.
Precisely. It's absolutely essential for identifying what's needed to close the gap between where you are and where you want to be. This informs the creation of roadmaps, helps evaluate different solution options, and is critical for planning migrations. It directly supports making those necessary adjustments and recommendations in a business environment.
Okay, seeing the gaps is key. What about seeing connections? Are there tools for that beyond the diagrams?
Yes. For seeing complex connections at a glance in a different format, the relationship matrix is invaluable. Its purpose is to provide a matrix-style view, think rows and columns, for convenient analysis of relationships between various architectural elements.
Like connecting stakeholders to requirements or use cases to features?
Exactly, those kinds of things. You can use it to see how stakeholders relate to specific requirements, how use cases link to functional requirements, or how specific application components relate to overall business requirements.
What's the advantage over just looking at diagrams?
The strategic advantage lies in helping to visualize potentially thousands of connections very compactly. It helps identify any missing or overlapping relationships, which can be a huge red flag for potential integration issues or gaps in coverage. And importantly, these matrices can often be exported to a spreadsheet application for further quantitative analysis, allowing for powerful data-driven insights into the architecture's structure. Now, when it comes to defining exactly what needs to be built or changed, the requirements diagram and the specification manager work hand in hand to ensure clarity and traceability.
Requirements, always crucial. How do these tools help?
The requirements diagram visually represents the relationships between requirements and other elements like business drivers, constraints, use cases, and components. It shows the context. The specification manager, on the other hand, is a central tool, often looking like a word processor or spreadsheet, for working with the requirements textually entering, maintaining, prioritizing, and viewing them.
So one visual, one textual.
Exactly. Its real strategic advantage is bridging that gap between textual requirements and visual models. It ensures traceability from high-level business drivers all the way down to the specific solution components being built or configured. This is absolutely crucial for managing the inherent complexity of project needs and ensuring that the technology solution ultimately delivered truly addresses the business problem it was intended to solve.
Traceability seems to be a recurring theme here. Makes sense. Now, in a world of constant change, how do you manage history? You mentioned auditing isn't for rollback.
Right. That's where time-aware modeling and baselines become absolutely essential for managing evolution and historical context. Time-aware modeling allows you to create distinct as-is current state and to-be future state models without altering your core baseline models. It's like working on different versions simultaneously. It supports cloning packages, diagrams, and elements, assigning version numbers, and maintaining trace relationships between the different states.
And baselines? Are they like snapshots?
Exactly. Baselines capture precise snapshots of architectural content, a whole package or model at a specific point in time. Think of it like saving a version of your entire city plan. You can then compare the current state to a previous baseline snapshot to visually see all the changes that have occurred, what was added, deleted, modified. And if necessary, you can potentially revert part or all of the model back to an earlier baseline state if a major error was introduced.
So that's the rollback capability.
Yes, the real strategic advantage here is profound. It's essential for managing complex enterprise transitions, clearly showing the evolution of systems over time and understanding the impact of changes. It provides a literal backup and recovery mechanism for architectural states, which is critical for maintaining consistency and control, especially when dealing with complex software and data integration across an enterprise over months or years. This brings us nicely to architecture principles management. These are kind of the guiding stars.
Architecture principles, like rules for building things.
Sort of, but more like enduring guidelines. Their purpose is to define high-level statements that guide the development of architectures and solutions across all domains: business, information, application, technology, security, and even cross-domain principles. These principles are typically established when an architecture program is first set up and are meant to be relatively unchanging pillars, reflecting the core values and strategic direction of the organization's technology strategy.
Who manages them? Do they ever change?
They're typically governed by an architecture board or a similar governance body. While intended to be enduring, they can be reviewed and updated periodically. And importantly, the board can issue dispensations, basically, documented exceptions which are recorded in a governance register for specific situations when following a principle strictly would lead to a detrimental outcome for a project or the business.
So there's some flexibility. What's the advantage?
The real strategic advantage is that these principles provide a consistent decision-making framework across projects and teams. They ensure alignment with enterprise values and strategic goals and help govern technology choices in a rational way, preventing ad hoc decisions. But, what happens to these principles when they're faced with new challenges, like the broad impact of technology on society and its security that we touched on earlier?
Yeah, how do abstract principles handle concrete new problems like AI ethics or IoT privacy?
That's a great question. Our architecture principles are not just internal guidelines anymore. They are increasingly becoming a reflection of our societal responsibility. As technology, whether it's AI, autonomous systems, or that vast network of IoT devices pushes ethical and environmental boundaries, our principles must proactively address concerns like privacy, data sovereignty, fairness, and environmental sustainability. We need to ensure our innovation serves society responsibly, not just efficiently.
So, considering unwanted byproducts, you mentioned waste and pollution earlier.
Exactly. Technological processes often produce these unwanted effects. Robust architecture principles, particularly for technology and even business process design, should guide design decisions towards solutions that mitigate these negative environmental impacts right from the outset, not as an afterthought.
And it's not just about mitigating negatives, right? You mentioned society's perception of risk changes, like the fast trains example.
Precisely. The technology and society source reminds us of this dynamic. Early railroads sparked fears of speeds above 45 mile per hour, something we find laughable now. This historical context relates directly to the initial apprehension surrounding things like the Internet of Things and that ongoing balancing act between fostering innovation and managing risk. Our EA principles must therefore account for this continuous innovation and the need for adaptation. They should guide us through evolving technological landscapes rather than becoming rigid obstacles that hinder progress. They need to be living documents that adapt, guided by ethical considerations as the world around us changes. And finally, underpinning all this collaborative work on architecture, we have security management within the EA tools themselves. This is absolutely non-negotiable in today's digital landscape.
Securing the architecture repository itself.
Yes, exactly. Enterprise architect tools typically employ a robust, role-based security system. It's designed to encourage collaboration while simultaneously restricting updates to specific sensitive parts of the model based on user roles and permissions. This means users, groups, and their permissions can be meticulously defined. For example, certain elements or diagrams can be locked to prevent unintended changes by unauthorized users. It often supports importing users from corporate directories like Active Directory for single sign-on, making it easier to manage.
And the strategic advantage, protecting the blueprints.
That's critical, yes. It protects vital architectural assets from accidental or malicious changes. It fosters controlled collaboration, ensuring the right people can contribute while maintaining integrity. This is especially important for safeguarding sensitive data definitions, security configurations, and strategic plans documented within the architecture repository itself. You need to ensure that your digital blueprints are secure.
This seems to directly reinforce the implications from the managing risk for IoT source we discussed.
It absolutely does. The same general cybersecurity challenges that plague the broader digital landscape, things like technological uncertainty, limited international cooperation, lack of incentives for vendors to build secure products, weak online identities, business models built on data exploitation. These are precisely the kinds of systemic risks that applying good enterprise architecture practices, including securing the architecture process itself, aims to mitigate.
So EA's security management capabilities are a direct application of those fundamentals of information technology concepts, security and privacy, providing structured control over the architecture.
Exactly. It ensures that even as technology advances and complexity increases, our security posture remains robust, considered from the very beginning, from the inside out, starting with the design itself.
Okay, this is making a lot more sense. The levels, the pillars, the tools, the governance. It's a comprehensive system, so let's bring it home. What does this all mean for your career for the listener, especially if you're a student here at Tarleton State, perhaps in BCIS 1305 or a related field. This isn't just abstract theory. It's about real-world application that can significantly impact your professional trajectory. It seems like it could separate those who simply use software from those who actually design the digital future of their company.
I think that's a great way to put it. Enterprise architecture provides a structured methodology for driving business improvement and achieving strategic alignment that, frankly, every business leader needs in today's world. EA tools are instrumental in understanding current states, the SOs identifying critical problems like redundancy, duplication, inefficiencies in processes or applications, and then designing optimized target states, the to be. It's a continuous cycle of analysis and improvement. Furthermore, EA greatly facilitates crucial communication among diverse stakeholders. Think senior executives, business users, technical teams. They all speak different languages sometimes. EA provides tailored, understandable views of complex architectures to bridge those gaps. A comprehensive communication plan, often supported by tools integrated within the EA suite like Model Mail or Calendars, is absolutely vital for the success of any major EA initiative. It ensures everyone is literally on the same page.
And it's not just about improving current operations, right? It seems invaluable for guiding big enterprise transitions.
Huge transitions, yes. Whether a company is modernizing decades-old legacy systems, merging with another company and integrating their IT, or maybe shifting to a completely new cloud-based operating model. EA defines the transition architectures. Those are the critical stepping stones that move the organization from a baseline state to a target state, often represented as a series of coordinated projects on detailed roadmaps over time.
And this feeds directly into effective portfolio management, making sure projects align.
Absolutely. It ensures that all projects and initiatives align with the overall enterprise architecture and contribute demonstrably to strategic goals. This maximizes true business value and helps avoid those costly detours or redundant projects that don't fit the bigger picture. And perhaps one of the most visible, high-stakes applications of EA's strategic value comes during major corporate events, like mergers and acquisitions, M&A, or corporate divestiture.
Oh, yeah. I can imagine the IT chaos during those without a plan.
It's often pure chaos. With EA, however, it becomes truly indispensable. It provides the framework for planning, assessing, and integrating, or conversely, strategically separating the IT landscapes during these incredibly complex events. It allows organizations to describe possible states of the enterprise post-event, anticipate challenges, streamline the technological integration or separation process, and ultimately save untold millions in integration costs, delays, and lost productivity. So considering all this, the tools, the processes, the strategic impact, it really leads us to ponder. In an era dominated by rapid digital transformation and pervasive concepts like the Internet of Things, how does enterprise architecture truly empower you, as a future business professional, to not just navigate, but to actually lead and shape this complex landscape?
Well, one of the most significant values seems to be EA's ability to bridge the gap between that high-level business strategy and the granular details of IT implementation, making sure tech serves the business. It ensures that every technological choice and investment directly serves clear business outcomes. This feels like the very core of those foundational skills in applying essential and emerging business productivity information technology tools that are so central to a course like BCIS 1305. It's about making sure your tech isn't just cool, but actually effective in achieving business goals.
Absolutely. And in today's interconnected world, enterprises contend with hundreds, if not thousands, of applications and an incredibly intricate web of relationships between them. It's mind-bogglingly complex sometimes. EA provides a structured way to manage this inherent complexity. It moves organizations beyond ad hoc reactive solutions to create a clear, understandable map of the entire technological landscape. This is critical for maintaining robust, scalable, and secure systems that can actually grow and adapt along with the business rather than holding it back.
And crucially, the tools within EA directly support informed decision-making. You mentioned features like decision trees graphically representing options, outcomes, risks, and benefits, while gap analysis highlights discrepancies and dashboard diagrams provide those quick, actionable summaries. These directly support problem-solving, allowing you to make data-driven adjustments and recommendations in any business environment. It relates closely to techniques like goal-seeking and what-if analysis that students learn to use in spreadsheets and other tools, applying that same analytical thinking to the bigger picture. It's about making smart, strategic bets, not just guesses based on gut feeling.
Well said. And the emphasis within EA on architecture principles, security, and privacy, especially as we discussed with the Internet of Things, inherently addresses ethical considerations in technology use.
It pushes you, as a future leader, to think about ethical business research and responsible technology deployment. For example, consciously considering the sensitivity of data and the criticality of function when designing IoT integrations isn't just good technical practice, it's becoming an ethical imperative in our digital world. We have to make sure our innovations truly serve people and don't create undue harm or risk.
And finally, maybe the most important thing for students. Enterprise architecture inherently promotes a mindset of lifelong learning and adaptability. Wouldn't you agree?
I couldn't agree more. The understanding that risk is dynamic and decreases as technology matures, and the constant need for evaluating and adapting architectural plans. It instills a habit of continuous career growth and learning. This is absolutely critical for students in fields like Management Information Systems, MIS, Computer Information Systems, CIS, and Information Technology, IT. It prepares you to embrace the ever-evolving nature of technology in business, ensuring you're always ready for what's next, always ahead of the curve.
Okay, fantastic. What a journey through enterprise architecture. Today, we really peeled back the layers, understanding its profound strategic importance for any organization, big or small. We explored how it provides that invisible yet crucial blueprint for business, information, application, and technology. And we saw how vital tools like process diagrams, component models, gap analysis, and strategic scorecards bring this grand vision to life in a practical way.
And we saw how this systematic, integrated approach to technology is absolutely crucial for managing the inherent risks and maximizing the benefits of rapidly evolving landscapes like the Internet of Things. It's really about ensuring that innovation doesn't outpace intelligent governance, that we're consciously shaping our technological future, not just reacting to whatever comes along.
From the earliest tools that reshaped human society to the complex digital ecosystems of today, technology has always driven change. That's undeniable. Enterprise architecture gives you the power to consciously, strategically, and ethically guide that reshaping within the business world. It gives you the power to not just navigate the future, but to actively design it. If you found this deep dive valuable, please show your support by liking this deep dive, subscribing to the deep dive, and sharing it with your network, your classmates, your colleagues. Don't forget, the description below is packed with additional resources and links to the sources we discussed today, so you can continue your learning journey.
And consider this as you move forward. What aspect of your future career, whatever path you choose, will most benefit from a deeper architectural understanding of the technology you'll inevitably encounter? How will you apply this kind of strategic perspective to create value and manage risk effectively in the organizations you join or even lead someday?
The future of business isn't just about what you know, it's about how you apply technology strategically to make it happen. Thanks for listening.